For this experiment, you will need a linear track that has been leveled, a shop vac connected up to it to make it virtually frictionless, a glider, a photo gate. On the glider, a blocker to read the times off the photo gate, an interface such as a Lab Pro, and to record the information from the Lab Pro, a calculator. You will also need for this experiment 8 50-gram masses and 2 springs. These springs will be connected on either side of the glider to the ends of the linear track. Now in this experiment, the glider that we're going to use has a mass by itself of 324 grams. Now for trial 1 of this experiment, with just the glider, we pull it back to a reference mark, turn on the shop vac to make the linear track virtually frictionless, release the glider for it to oscillate through the photo gate, and the Lab Pro will measure its period and will display that information on the calculator. Now this is the program we'll be using in this experiment. This program will determine the period of the oscillating glider as it goes through the photo gate. So for trial 1, with just the glider, pull it back to the reference position, release it, and measure the period for 3 complete oscillations through the photo gate. So for trial 1, you can see the average period is 1.2992 seconds. Now for trial 2, we add a 50-gram mass to the glider. And we pull the glider back to the same reference mark and release it for the Lab Pro to measure its period. So for trial 2, with the glider plus 50 grams, you can see the period at the top of the screen there, 1.3996 seconds. And we'll just continue adding 50 grams to the glider each time and measuring the period for 3 complete oscillations. Now here's the last trial with 8 50-gram masses on the glider, and you can see the period is 1.9402 seconds. Now with this data and the worksheet that accompanies this video, determine the relationship between the mass of the object in simple harmonic motion and its period of vibration.